Hi, welcome to Apache Hadoop 3x course. I'm Abhishek Sakuja from UpDegree, and in this video we are going to continue an introduction to 2x. So in our previous video we have already taken a look how exactly the NameNode HA works, and in this video we are going to look the architecture of a yarn, or we can say the resource manager, how exactly things work from computation point of view. So first of all, what are the different components do we have in this design? So first we have here the resource manager, we have the node manager, the container, and the application master. So let's say on the left hand side we have two client requests to do some computations on the cluster. So first of all, the clients get in contact with the resource manager. He writes the let's say he writes the complete command yarn and take this jar, and this is the input, this is the output, could you please run a program for me, let's say a word count program, which we have already seen that how exactly a word count program works in MapReduce. So in that, the client first of all get in contact with the resource manager saying that this is the job I had, can you take this job and distribute on the cluster and get it done for me. So the client just send the job, that's it. So there are two clients, one you can see it's in light pink and one is in your light purple color, right? This is the representation how the jobs works on the cluster. So the first clients get in contact with the resource manager. Now what resource manager do, if we go back to the presentation, on the right hand side there are two kind of responsibility we can see. One is for the resource manager, one is the scheduler, another one is the app manager. Here the resource manager take those responsibility very seriously, and according to that he will do the scheduling of the job. But before scheduling of the job, we have already seen that there is another kind of component inside resource manager, which is the application manager, or application that's the management that it will do in the cluster for the applications. So that application manager, what it will do, it will first of all get to the cluster and see that where do we have the availability. And that is how the name of the yarn came of, which is yet another resource negotiator. So that application manager is actually going to go in the cluster and create a application master over there. Now this application master, what exactly it does, it try to negotiate the resources within the cluster and get the information to the resource manager. But this is per application. So whenever the resource manager within the resource manager, the application master is going to create application manager is going to create the application master. It is on the temporary basis. Why it is temporary basis? Because each application has its own application master, which will sit inside the cluster for a temporary basis, look everywhere for the resources and get back to the resource manager saying that this particular node has some resources, this particular node has some resources. They already have the data locality information, that where exactly the data located. According to that, it will go to the nodes and find the place where it can run the application efficiently. So once the resources known by the resource manager through the application master by the application, for the client, if you can see, for the first client we have the application master on node 2, right? This is the node where we have the application master for that, and you can see that only one application master for this client has been created because it requested only single application. Once this application master gives the information to the resource manager, now resource manager start doing the scheduling. That's the second component that we have read inside the resource manager, is a scheduler. So it will take the scheduling to the cluster, right, and it will inform the node manager that this is the resources that we have. Actually this is not going to inform to the cluster. The node manager get in contact with the resource manager saying that what is the job for me to do. So then it will inform we have this particular application which is a word count program, and it required these many resources, so please go ahead and create those containers. So if you see that now we have something called as container. So these, what is the container? Container is a set of resources which is a collection of your CPUs and RAM in which your application get executed. So who creates these containers? Containers are created inside the node, means the slave nodes, and the node manager is actually responsible of creating these containers. So this particular node manager will create this container, and this on the third, if you see, the node manager contain two containers. Why do we have two containers? Why do we have one container over here? This is just say about the number of blocks that are node manager 3 are more than the on node manager first. So therefore we have the only one container in this on the first node, and on the third node we have two different containers to run the blocks which are present on those data nodes. But if you see that on the third on the middle one, on the node manager 2, we do not have any container, which means that there is no data that has to be processed for that application on this particular data node. So therefore there is no. So once the container finishes the application, like saying that, you know, we are done, and to where they report the application status, it's to their application master. That's what it is pointing, that it is pointing towards the application master, and application master get the status to the resource manager. So once the job is done, application master will say, yes, the application has been completed. We can redirect the request to the client saying that your job is done. And then the node manager will also come to know that yes, the job is done, and it will start killing the containers. Similarly, for the second client, it is the same way. The second client goes to the resource manager. Resource manager will create an application master. Application master will do the resource negotiation, find that where is the data block that it needs to run, give the information to the resource manager. The node manager get in touch with the resource manager, and finally it will ask to create the container. Container will run the job and give the information to the application master, and from there, once the job is done, node manager is going to kill the container, and application is completed for the client. So this is how your yarn architecture works. Now let's take a look improvement over 2x. So what are the improvement that has happened from 1x to 2x? The 1x was moreover for batch processing, because MapReduce was completely embedded into in 1x, and MapReduce is a batch oriented processing. So therefore there is no way that we can run any time of streaming or real-time processing. But with Hadoop 2x, it became possible to do a batch and a real-time processing. Job tracker was overloaded. Now we have already seen that, you know, earlier the job tracker was is the one who's responsible for scheduling, for tracking, for doing the for completely assigning the task, and doing the resource manager. So every work that has been given was to the job tracker. So do everything, the complete application management will be done by the job tracker. So the job tracker was overloaded in Hadoop 1x. With Hadoop 2x, the resource manager has offloaded the task. So it will say, I will sit there, I will take two job responsibility. One is the scheduling of the job. The second one is the application master. So application management. So in that way, what it has done, it has offloaded its works, some to the containers, like which has been managed by the node manager, and the other has been managed by the application master. So therefore, the resource manager will say, okay, I'll sit, just give me the job to do, and I'll complete with scheduling and doing the application management. That's it. So Hadoop 2x is Hadoop 1x was a single point of failure, because if the master, which is our name node, goes down, we have already seen in the architecture, then everything is down, then the cluster is down, and to make it available again, we have to make the secondary name node manually up so that it becomes a primary node. So there's lots of overhead on that, and that makes a single point of failure. But with 2x, we have a high availability. We have already seen that now we have active and standby name node. Active goes down, the standby will become active at the same point of time without any manual intervention. Single programming model, MapReduce, was only available in 1x. There is no other processing model or the programming model you can have on top of 1x. So that was one of the biggest drawback. With 2x, now you can have multiple programming models, like you can have MapReduce, interactive, streaming, graph, Spark. So whatever the different kinds of modeling that you want to do, you want to do batch, you want to do real time, you want to do streaming, you want to do graph analytics, everything was possible with Hadoop 2x, even with the data science. Then with 1x is a single tenant support, and with 2x is a multi-tenancy support, which means that earlier, if you have one cluster and you want to run for one team, it is just specific for one team. You cannot do for multiple teams or say about multiple groups or multiple departments within one cluster, right? One cluster was dedicated to just one kind of group and nothing else. With 2x, you can have like you want to have a development group, you just segregate the development group resources. You want to have UAT group, you just segregate all those UAT resources for the cluster. That is possible with the schedulers that we have Hadoop on Hadoop 2x. And finally, support of only 4096 nodes per cluster. Why there was a limit? Because the job tracker was overloaded, and it was figured out like after these many nodes, the job tracker was failing. So you need another cluster. With 2x, the support was a 10,000 nodes plus cluster. So till then, your cluster will work fine. All right, so this is what we have in this video, and in the next video we are going to take a look at an introduction to Hadoop 3x. Thank you.